Each year, humanity consumes more than 50 billion tons of sand. More than all the oil, steel, and coal combined. Not to eat, not to burn, but to build homes. In some countries, entire rivers disappear within a few years, drained at night by sand dredgers. No war, no natural disaster, just concrete rising somewhere else. It starts after midnight. A pump is lowered into the riverbed. Sand, water, and silt are pulled up together. Several tons per minute. No paperwork, no measurements, only volume. The operation runs on time. 2 hours is enough. 3 if the river is deep. Trucks wait nearby. When one is full, another takes its place. The sand never stops moving. Someone watches the road, not to call the police, to warn if they appear. In some regions, officers have tried to intervene. Some were transferred. Some were attacked. A few were killed. The conflict is rarely recorded as theft. It is labeled as an accident, or not labeled at all. By sunrise, the trucks are gone. The river looks unchanged from the surface, but the bottom is lower. The current is faster. The banks have lost support. No bridge collapses that morning. No house falls into the water. No emergency is declared. The damage accumulates silently, measured in centimeters and months, not headlines. What disappears that night will reappear elsewhere, mixed with cement, stamped as legal, and sold as progress. For decades, sand was treated as background noise. It was never listed beside oil, gas, or rare metals. It did not appear in geopolitical risk reports. It was assumed to be endless. That assumption collapsed quietly. Every year, the world consumes more than 50 billion tons of sand and gravel. This is not an estimate pulled from a single industry report. It is a synthesis of construction data, infrastructure spending, and material flow studies across multiple regions. To put that number in context, global oil production sits below 5 billion tons a year. Steel production is under 2 billion. No other solid resource on Earth is extracted and moved at this scale. The reason is simple. Modern cities are built on concrete. Concrete is mostly sand. Roads, bridges, ports, dams, airports, housing blocks, flood barriers, data centers, industrial parks. None of it exists without sand of a specific size, shape, and mineral composition. Not all sand qualifies. Desert sand is too smooth. Ocean sand corrodes steel. Only sand from rivers, lakes, and coastlines binds properly. And that kind of sand is finite. Urbanization turned this constraint into pressure. Between 2000 and 2020, global urban floor space more than doubled. China alone poured more concrete in 2 decades than the United States did in the entire 20th century. India adds millions of new urban residents every year. Southeast Asia expands ports, highways, and industrial zones at a pace unmatched in history. Each square meter locks in sand consumption that cannot be recycled at scale. As demand accelerated, extraction followed. Official permits account for only part of the supply. In many regions, legal production cannot meet construction timelines or price targets. The gap is filled informally, sometimes illegally, sometimes semi-legally, under permits that exist on paper but not on the river. This is where scale becomes invisible. A single dredger pulling a few hundred tons a night seems insignificant. Multiply that by dozens of sites along one river. Multiply that by hundreds of rivers across multiple countries. Multiply that by years. Entire river systems are lowered by meters, not millimeters. The math is slow, but it is relentless. The United Nations Environment Program has warned that sand extraction now exceeds natural replenishment rates in most major river basins. Rivers do not simply carry water. They carry sediment. When sediment is removed faster than it is replaced, the river responds mechanically. It deepens its channel. It accelerates flow. It eats its own banks. Infrastructure designed for a stable riverbed begins to fail. Some countries import sand openly. Others deny doing so while quietly relying on intermediaries. Singapore has expanded its land area by more than 20% since independence. It has no domestic sand resources. Its imports have reshaped coastlines in neighboring countries, some of which have since imposed export bans that are widely bypassed. The trade does not stop. It reroutes. In Africa, rivers feeding coastal cities have been stripped to supply concrete for housing and ports. In South Asia, riverbeds near megacities are mined nightly to keep pace with real estate expansion. In parts of Southeast Asia, sand extraction is linked directly to organized crime networks that control transport routes and protection. This is not speculation. Arrest records, court cases, and investigative reports document it repeatedly. The key detail is that sand does not disappear when it leaves the river. It becomes invisible. Once mixed into concrete, it loses its origin. No building carries a label saying where its sand came from. No financial report traces sediment back to a specific riverbank. The supply chain ends the moment concrete hardens. From the perspective of the city, the material is clean. From the perspective of the river, it is gone. At this scale, the damage does not announce itself. It accumulates. One bridge foundation weakened here. One water table lowered there. One fishing community losing its shoreline. These effects remain disconnected until they cross a threshold. When they do, they are framed as natural erosion, infrastructure failure, or climate impact. Rarely as extraction. The world did not run out of sand overnight. It normalized removing it faster than it could be replaced. And it built entire economies around that assumption. What began as a background material has become one of the most aggressively exploited resources on the planet. Not because it is rare, but because modern life cannot slow down enough to notice what it is destroying to stay upright. The paradox begins with a simple question. If sand is everywhere, why is the world running out of it? From space, deserts dominate entire continents. Beaches stretch for thousands of kilometers. The planet looks buried in sand. Yet the construction industry is facing shortages, price spikes, and supply conflicts. The contradiction is not visual. It is physical. Not all sand behaves the same. Construction-grade sand must be angular. Its grains need sharp edges to lock together when mixed with cement. River sand meets this requirement because it is broken down mechanically over time. Desert sand does not. Wind erosion smooths its grains until they slip past each other. It cannot bind. Adding cement does not fix this. The structure fails under stress. Ocean sand presents a different problem. Salt accelerates corrosion in steel reinforcement. Washing it is expensive, slow, and rarely done at scale. By the time ocean sand is treated to acceptable standards, it is no longer cheap. The economics collapse. This leaves rivers, lakes, and coastlines as the primary sources. These systems are finite and slow to regenerate. A healthy river replenishes sand through upstream erosion and sediment transport. This process takes decades. Industrial extraction removes in hours what nature replaces in years. The paradox deepens when urban growth is added. Cities demand sand continuously, not in pulses, not seasonally. Every housing project, road expansion, and port upgrade locks in future demand. Concrete does not circulate back into rivers. Once sand enters the built environment, it is effectively removed from the natural system. Attempts to substitute materials have failed to scale. Crushed rock works in limited applications but requires energy-intensive processing and generates emissions. Recycled concrete exists, but its global contribution remains marginal compared to demand. Innovation has not outrun consumption. Regulation does not solve the paradox. It shifts it. When one country restricts river mining, extraction moves upstream or across borders. When exports are banned, intermediaries emerge. The supply chain fragments, but the pressure remains. Cities do not pause construction because a river is collapsing hundreds of kilometers away. The economics reinforce this behavior. Sand is cheap relative to the value of finished buildings. Even large price increases barely register in project budgets. Developers absorb the cost. Governments prioritize housing targets and infrastructure timelines. The signal to stop never arrives. Environmental damage compounds quietly. Lower riverbeds increase flow velocity. Faster water erodes banks and destabilizes foundations. Groundwater tables drop as sediment layers thin. Saltwater intrudes inland. These are mechanical outcomes, not abstract risks. but they appear gradually, making attribution difficult. The paradox is not that sand is scarce. It is that demand ignores replenishment. The planet has sand. The system does not have time. Cities are designed to grow faster than rivers can heal. Concrete hardens in days. Sediment recovers in generations. The mismatch is structural. Once this gap opens, it cannot be closed by efficiency or enforcement alone. The built environment depends on a resource that behaves like it is renewable, but is extracted as if it were infinite. That is the core contradiction. A world covered in sand has organized itself around the fastest way to run out of the only kind it can use. The sand economy does not rely on chaos. It relies on routine. Extraction follows a predictable pattern. It begins at night or before dawn, when visibility is low and oversight is minimal. Pumps are lowered directly into riverbeds. In shallow areas, excavators scrape sediment from exposed banks. In deeper channels, suction dredgers operate continuously, pulling up sand mixed with water and silt. The process is fast. A single machine can remove hundreds of tons in hours. The first transfer point is local transport. Trucks or barges wait nearby. Loads are moved immediately to avoid accumulation at the site. Speed matters more than efficiency. The goal is not optimization. It is invisibility. From there, sand enters a gray zone. Some loads carry permits issued for different locations or volumes. Others rely on reused paperwork, altered timestamps, or informal clearance agreements. In regions where enforcement exists, extraction rarely stops entirely. It adapts. Routes shift. Sites rotate. Responsibility fragments. Local officials play a structural role. Permits are granted based on quotas that rarely match actual demand. Once construction accelerates, legal supply becomes insufficient by design. This gap is filled quietly. In some cases, authorities tolerate informal extraction to keep projects moving. In others, enforcement targets small operators while larger networks remain untouched. The appearance of control is maintained. The next layer is processing. Sand is washed, sorted, and mixed at depots that operate both legally and informally. Once blended, origin becomes untraceable. Grain size is standardized. Moisture is adjusted. By the time the material leaves the yard, it is no longer river sand. It is inventory. This is where laundering occurs. Construction companies purchase sand through intermediaries who provide invoices, tax documentation, and compliance statements. These documents reference licensed suppliers, approved extraction zones, or recycled sources. Verification is rare. The volume of transactions overwhelms inspection capacity. Financial flows reinforce the system. Sand transactions are low margin but high volume. Payments are fragmented across multiple buyers and sellers. Cash is common at early stages. By the time the material reaches major projects, transactions are formalized. Risk has already been absorbed downstream. Organized groups exploit this structure. Control over extraction sites grants leverage over transport routes. Control over transport grants influence over pricing. Violence is not constant, but it is available. It is used selectively to enforce territory or discipline competition. In many regions, sand disputes account for a growing share of environmental crime cases. Yet the machine does not depend on criminality alone. It depends on demand certainty. Cities do not pause for audits. Infrastructure deadlines do not wait for sediment recovery. Once concrete schedules are set, sand must appear. Import networks extend the machine across borders. When domestic sources are restricted, sand is sourced from neighboring countries. If exports are banned, it is rerouted through third-party ports. Shipping manifests list aggregate, fill material, or reclaimed sediment. Classification changes. The flow continues. At each step, responsibility is diluted. Extractors claim they are meeting market demand. Transporters claim they are moving approved material. Developers claim compliance with procurement standards. Governments claim enforcement constraints. No single actor controls the system. That is its strength. The final stage is incorporation. Sand becomes concrete. Concrete becomes structure. Once poured, the supply chain ends. There is no recall. No audit. No visible trace of origin. Buildings do not reveal the rivers they consumed. This is why the system persists. It does not require conspiracy. It requires alignment. Construction timelines, regulatory gaps, and economic incentives point in the same direction. Removing friction slows development. Allowing flow sustains growth. Crackdowns produce temporary disruption. Machines are seized. Operators are arrested. Media coverage spikes. Then activity resumes elsewhere. Extraction sites migrate upstream or downstream. New intermediaries emerge. Permits are revised. The machine adjusts. Technology has not exposed the system. Satellite imagery can identify dredging scars, but enforcement remains local. Tracking sand at scale requires political will that conflicts with development goals. Few governments are willing to slow construction to protect sediment. The invisible machine thrives because it is normalized. Sand is treated as bulk material, not as a strategic resource. Its removal is categorized as environmental impact, not structural dependency. As long as cities measure success in square meters built and kilometers paved, the machine will be fed. Nothing about this process is hidden to those inside it. What remains invisible is the connection between a specific riverbed and a specific building foundation. That gap is the machine's most valuable asset. It allows sand to move from ecosystems to balance sheets without ever appearing as loss. The damage does not appear evenly. It follows geography, governance, and demand. In river systems across South and Southeast Asia, extraction lowers riverbeds year after year. When the bottom drops, water accelerates. Faster flow strips banks of sediment that once stabilized them. Farmland collapses into channels. Homes that stood for decades lose their foundations within a single season. Compensation rarely matches loss, because erosion is classified as natural. In India, multiple states report bridges weakened as supporting sediment disappears beneath pylons. Repair costs are absorbed as infrastructure maintenance, not extraction damage. The accounting disconnect allows the cause to remain invisible. What failed is recorded. What triggered it is not. Along the Mekong Basin, sand removal compounds upstream dam impacts. Reduced sediment flow starves downstream deltas. Shorelines retreat. Salinity moves inland. Rice yields fall gradually, then suddenly. The timeline stretches beyond election cycles, which makes intervention politically unattractive. Island nations experience the damage more directly. In parts of Southeast Asia, small islands have lost measurable land area within a generation. Some have disappeared entirely. The material did not erode naturally. It was exported. Satellite imagery confirms extraction patterns, but responsibility is diffused across buyers, brokers, and ports. In Africa, urban expansion pulls sand from rivers that supply drinking water. As riverbeds deepen, groundwater tables drop, wells dry up, communities drill deeper, increasing costs and contamination risk. Water scarcity emerges without drought. The cause is mechanical, not climatic. Coastal cities face a different profile. Sand mining weakens natural barriers. Beaches thin. Storm surge penetrates further inland. Protective infrastructure becomes necessary sooner than planned. Budgets are redirected from development to defense. The original extraction appears cheap only because future costs are deferred. In China, rapid construction has driven demand beyond domestic river capacity. Regulation has tightened, but extraction has shifted toward inland waterways and reclaimed sources. Sediment removal interacts with flood control systems, altering flow dynamics in ways that require constant engineering correction. Stability becomes a managed state, not a natural one. Across Latin America, illegal sand mining intersects with organized crime. Control over extraction zones mirrors control over other commodities. Environmental damage is paired with labor exploitation and violence. Enforcement actions address surface offenses while leaving supply incentives intact. What connects these regions is not culture or policy. It is flow. Sand moves from weakly governed environments to capital-intensive construction markets. The benefits concentrate. The damage disperses. The losses are cumulative. 1 meter of riverbed lowered here. 1 hectare of land lost there. One community relocated without recognition. Individually, these are manageable. Together, they redefine landscapes. Environmental assessments struggle to capture this accumulation. Projects are approved based on localized impact studies. Regional extraction totals remain fragmented across jurisdictions. No authority tracks sediment loss across entire basins. The system measures transactions, not depletion. Insurance absorbs part of the cost. Flood claims rise. Structural failures increase. Premiums adjust. Risk is priced, not prevented. This further distances cause from effect. The river does not appear on the balance sheet. Climate change amplifies existing damage. Altered rainfall patterns increase stress on already destabilized systems. But attribution remains skewed. Flooding is blamed on extreme weather. Erosion is blamed on nature. Sand extraction is rarely foreground. The global map of damage is not marked by sudden collapse. It is marked by thresholds. Once crossed, recovery becomes expensive or impossible. Deltas sink. Aquifers salt. Infrastructure ages faster than designed. Cities importing sand experience none of this directly. Their rivers remain stable. Their coastlines are protected. Their buildings rise on schedule. The cost is externalized, geographically and politically. This separation allows consumption to continue without friction. The places that lose land are rarely the places that gain floor space. The trade balances. From the perspective of global development statistics, progress continues. Urban density increases. Infrastructure expands. From the perspective of sediment systems, the ledger moves in one direction. Sand leaves rivers. Concrete hardens. Landscapes adjust downward. The damage is not hidden. It is redistributed. It usually starts with a small change. The river is closer than it used to be. Not much. A few steps. People notice, but they don't panic. Rivers move. That's normal. Then one morning, a section of the bank collapses. No noise. No warning. Just a chunk of land sliding into the water. A fence goes with it. Then part of a garden. The house is still standing. For now. The owner calls the local office. They come, take photos, write notes. Erosion, they say. Seasonal. Nothing illegal. At night, the pumps return. This is how it works. The damage shows up during the day. The cause works after midnight. A few weeks later, the river is wider. The current feels faster. Boats don't tie up where they used to. The water pulls harder at the edges. People stop letting their kids play near it. One night, someone hears the machines from inside the house. Low noise. Constant. Like breathing. It goes on for hours. By the time it stops, the ground is already weaker. The collapse happens before sunrise. Part of the house drops straight down. Not slowly. Not dramatically. Just gone. The rest tilts and cracks. Furniture shifts. Walls split. Nobody dies. That's how it's reported. No fatalities. What's lost isn't counted. The land had no clear market value. The house wasn't insured for river failure. Compensation comes months later, if it comes at all. It's not enough to rebuild. It never is. The family moves inland. Temporarily. That temporary place becomes permanent. Downriver. Nothing changes. Trucks still come. Concrete still gets poured. The sand from that stretch of river is already part of something else. A road extension. A housing block. A port upgrade. No one connects the two. In some cases, people try to intervene. A group blocks the access road one night. They stand there with phones, recording. The operators don't argue. They leave. The next night they come back. Same machines. Different route. Sometimes police show up. Sometimes they don't. When they do, it depends on who called first. In a few documented cases, the confrontation turns physical. Officers seize equipment. Operators resist. Someone gets hurt. In rare cases, someone is killed. It makes the news briefly. The headline focuses on violence, not sand. After that, Extraction pauses. Not stops. Pauses. The site shifts upstream, or downstream, or across the border. The river is long. Jurisdiction ends quickly. For the people living there, the pattern is clear. Loss comes in pieces. A little land each year. A well that turns salty. A road that cracks sooner than expected. Fishing that gets worse without explanation. No single event is enough to trigger emergency response. Together, they change everything. What makes this harder is that the damage feels personal, but the cause is not. It's not one neighbor, not one company, not one official. It's a chain. The person who lost the house can't trace it. They know the river changed. They know machines came at night. They don't know where the sand went. Even if they did, it wouldn't help. The building it became is legal. The project has permits. The developer followed procurement rules. The concrete passed inspection. Everything checks out. That's the gap. The system breaks harm into pieces small enough to ignore. In interviews, officials often say the same thing. We need development. We need housing. We need infrastructure. Sand is necessary. They're not wrong. What they don't say is where the cost lands. It lands where land has no paperwork, where erosion looks like nature, where people don't have the leverage to slow a project thousands of kilometers away. In some communities, relocation becomes normal. Houses are rebuilt further back, then rebuilt again. Each time smaller, each time poorer. People adapt until they can't. Years later, when flooding becomes severe, studies are commissioned. Reports mention altered sediment flow, reduced river stability, human activity as a contributing factor. The language stays careful. No blame. By then, the river is already different. Deeper, faster, less predictable. The loss is no longer just land. It's certainty. People stop knowing where it's safe to build, or plant, or stay, and still sand moves. Not because anyone wants this outcome, but because no one is positioned to stop it. The city that used the sand never sees the house fall. The river that lost it never sees the building rise. One side calls it progress. The other calls it home. They never meet. The consequences don't arrive like disasters. They arrive like maintenance issues. A road needs repairs sooner than expected. A bridge shows cracks that weren't there in the original design. A building settles unevenly. Engineers write reports. Budgets get revised. Life goes on. What changed is underground. When sand is removed from river systems, sediment layers thin out. Those layers don't just support riverbanks. They regulate groundwater. They distribute pressure. They slow movement. When they're gone, everything above them behaves differently. In many growing cities, groundwater extraction is already high. Wells pull water faster than aquifers can recharge. When sediment layers are intact, the ground compresses slowly. When they are weakened, compression accelerates. Land sinks. This is subsidence. It's not dramatic. It's measured in centimeters per year. But over a decade, those centimeters become structural problems. Drainage systems stop working properly. Flood risk increases even without heavier rain. Pipes break more often. Roads need constant leveling. Cities respond by engineering around the problem. Pumps are installed. Barriers are raised. New standards are written. Each fix assumes the ground will remain stable enough to justify the next one. That assumption grows weaker over time. The link to sand extraction is rarely made explicit. Subsidence is blamed on groundwater use. Flooding is blamed on climate. Structural stress is blamed on aging infrastructure. Each explanation is true on its own. Together, they hide the underlying dependency. Riverbeds lowered upstream change how water arrives downstream. Faster flow during heavy rain increases flood peaks. Reduced sediment reduces natural elevation gains in deltas. Coastal cities sink while sea levels rise. The margin for error disappears. Some cities are already living with this reality. Parts of them sit below sea level. They rely on constant pumping to stay dry. Power outages become existential risks. Flood defenses turn into permanent fixtures, not emergency tools. These are not future scenarios. They are ongoing conditions. The problem compounds because construction doesn't slow down. New districts are built while old ones require reinforcement. The material that caused instability is used to extend the city further into vulnerable zones. The feedback loop tightens. Insurance markets react before policy does. Premiums rise. Coverage exclusions appear. Risk is priced in quietly. Homeowners pay more. Governments subsidize. The cost spreads. At some point, adaptation stops making sense. Infrastructure upgrades exceed economic return. Neighborhoods are rezoned. Retreat is discussed, then postponed. No one wants to be the first to admit a city was built on a bad foundation. Sand extraction doesn't cause collapse on its own. It removes buffers. It reduces tolerance. It turns extreme events into normal stressors. What makes this dangerous is timing. The damage appears long after the sand has been poured into concrete. Accountability fades with distance. The people making procurement decisions are not in office when the consequences surface. Urban planning works on decades. Sediment systems work on centuries. Development compresses both into years. Once subsidence sets in, reversal is almost impossible. You can stop pumping water. You can reinforce structures. You cannot easily put sediment back where it was. Rivers do not forget their altered paths. The result is a class of cities that function only as long as systems hold. Pumps must run. Barriers must stand. Budgets must cover constant intervention. Any disruption magnifies risk. From the street level, this feels like bad luck. From the system level, it is design. Cities didn't intend to depend on disappearing rivers. They optimized for speed, cost, and scale. Sand made that possible. Now the question isn't whether development used too much sand. It's whether modern urban life can slow down enough to account for what it removed. Most cities won't stop building. They'll adapt until adaptation fails, or until the cost becomes visible enough to name. By then, the concrete will still be standing. The rivers will not. The river looks calm again. From the surface, it's hard to tell anything happened. Water moves. Reflections hold. If you didn't know the history, you wouldn't stop. This is how most extraction ends. Not with collapse. With forgetting. The machines are gone. The tracks on the bank fade after the next rain. Grass grows back in uneven patches. Officially, nothing is happening here anymore. But the river remembers. Its channel is deeper. Its flow is faster. The edge is closer than it used to be. The change is small enough to ignore, until it isn't. Upstream, another site opens. Downstream, the current adjusts. The system keeps moving. Somewhere else, concrete is being poured. Workers level the ground. Forms are set. The mix arrives on schedule. No one asks where the sand came from. It doesn't matter. It passed inspection. It hardened. That's the end of the story for the city. There's no label on the building. No marker that says this wall used to be part of a riverbank. No record connecting the two places. Time and distance do the work. This separation is what makes the system stable. Loss happens where it's cheapest to absorb. Value appears where it's easiest to measure. Development statistics improve. Land quietly disappears. People who lived near the river adjust. They move back, or move away. They learn how far the water comes during the rainy season. They stop rebuilding certain rooms. They adapt without calling it adaptation. Years later, when flooding worsens or foundations weaken, explanations arrive ready-made. Climate change, aging infrastructure, unusual weather. All true, all incomplete. The river is rarely mentioned. Sand was never meant to be strategic. It was supposed to be background, something too common to matter. That assumption built the modern world faster than any plan could have. Now the cost is showing up in places that don't have the leverage to push back. In centimeters, in repairs, in relocations, in silence. Nothing about this required bad intentions. It required alignment. Cities that couldn't slow down. Markets that couldn't wait. systems that measured output but not depletion. The river doesn't argue. It adjusts. If extraction stops tomorrow, the damage doesn't reset. Sediment takes decades to rebuild. Channels don't return to their old paths. Some changes are permanent. Most people will never see the river that paid for their building. They'll walk on finished floors, drive on smooth roads, trust foundations they never think about. That's how the system holds, by keeping the source out of sight. The question isn't whether cities should be built. They already are. The question is simpler and harder. When the ground beneath modern life is quietly removed, how long can everything above it pretend nothing is missing?